the second part of the question here is area of triangle OBC. That means this triangle OBC, area of this triangle, plus area of triangle OAD. OAD is this triangle. The sum of the areas of this triangle, they are saying you have to show that it is equal to area of half the parallelogram. So in this case, we had drawn a horizontal line there. In this case, we'll draw a vertical line that passes through O. Okay. So let us call this P and Q. Now again, if you see triangle OBC, that is this triangle, is half the area of triangle, half the area of parallelogram QBCP, this parallelogram, and this area of this triangle is half of area of this parallelogram, right? And now if I add up both the areas, I'll get half area of this parallelogram on the right hand side and area of parallelogram on the left hand side, and if which is equal to half area of the entire parallelogram ABCD, right? So exactly similarly we can prove, isn't it? Did you understand what I said?
Yes, sir.
Yes, sir.
So let's do this, finish this off. So you need to show that area of parallelogram, that triangle OBC plus area of triangle OAD is equal to half area of parallelogram ABCD. So here in this case, in order to prove the second part, proof of 2, we draw PQ parallel to AB parallel to DC. Sorry, PQ parallel to this line, PQ parallel to AD parallel to BC. Okay. Okay. So now, which are the two parallelograms that we need to identify? So you have AQPD as your parallelogram. AQPD is a parallelogram. And what is the other parallelogram? QBCP. QBCP is a parallelogram. Okay. Now what can I say about triangle OBC? Area of triangle OBC is half of which parallelogram? Can you look at the figure and tell me which parallelogram? OBC? QBCP. I hope this you can see the alphabets, right? Are the alphabets? Can you see the alphabets that I have written?
Yes, sir.
Okay. So area of OBC is equal to half of area of parallelogram QBCP. Okay. And the reason remains the same, that area of triangle is half area of parallelogram on the same base. This time, which one is the base? Which one is the base? In case of OBC, BC is the base, right? And between what parallel lines? PQ parallel to CB. PQ parallel to CB. Fine. Now we consider the next triangle, OAD. Area of triangle OAD is equal to half of which parallelogram? AQPD, right? AQPD. And the reason remains the same. This reason and this reason remains the same. Now adding 1 and 2, what do you get? Area of triangle OBC plus area of triangle OAD. OBC plus OAD is equal to half area of what parallelograms? QBCP plus AQPD, right? And now you can take half common and write this again as QBCP plus AQPD. And what is the sum of the areas of these two parallelograms? It is area of parallelogram ABCD. And then that is the required proof. Clear with this? Can I proceed to the next question? Okay. The next question that I want to do is 6B. Look at this question. Let me put it a little bigger for you. Yes, this is the question. Okay, this is the figure. This one is the figure. So if you read the question, it states in the figure given below, PQRS and ABRS are parallelograms and X is any point on the side BR. Okay, so which one are the parallelogram? Let's identify the parallelograms first. PQRS. This is a parallelogram PQRS, right? What is the other parallelogram? ABRS. This is another parallelogram, right? So these two are parallelograms. What do you have to show? You have to show that area of triangle AXS. So which is the triangle here? This is the triangle. Area of this triangle AXS. Area of this triangle is half area of parallelogram PQRS. This parallelogram. Okay. The area of this triangle that I have outlined in black is equal to half of area of parallelogram that is outlined in